work on tonight?
I'm having trouble with mainly like logarithms
Okay.
and like trigonometry in general.
Okay. I think I can help a lot with logarithms if we talk about this. This is an exponential equation. It's exponential because the variable x is in the exponent. It's not on the equation line. It's significantly different than something like that. When x is in the exponent, it's no longer an algebra equation. That is an exponential equation, okay? An example would be 8 equals 2 to the third power. Well, whenever you have an exponential equation, it's very, very important that you know how to express this logarithmically. And you only have to remember one thing. Logs are exponents. So if I want to express this thing logarithmically, I can start right there. Now, I still have to put the y and the b somewhere. Where does the b go and where does the y
go? They go, well, one goes right next to log and then one goes like under.
The b is always the base. So it's going to go down there, and the only other place for the y is there. Okay? So, if I had the exponential expression 8 equals 2 cubed, what would the equivalent logarithmic expression be?
It would be log 8, or log 2.
Log base 2.
Log base 2, and then 8 equals 3.
Okay. And the biggest thing about logs that you be able to go back and forth between these two expressions. In other words, if somebody gives you that, you should be able to express it logarithmically. Or if somebody gives you the log expression, you should be able to express that exponentially. Okay, that's the most important thing about logs. If you can do this, if you can go back and forth between the two, you've made a huge leap in understanding logs. Now, you said logs and trig. Well, logs would be an hour session unto itself, and trig would be like a 6-hour session. So I suppose I need a little more specifics from you. Do you have specific log problems that you'd like to look at, or specific trig problems?
I have a couple trigonomic questions, I think.
Okay.
So the first one is y equals sine 0.5, and then crap, what's it called? Parenthesis. It's a grouping.
The parentheses after the 5?
Not a parenthesis. Is that what it's called?
Not sure what you're trying to.
It's a grouping like symbol. Crap.
Did you send me any photos last time we had a session?
No.
Let's get that down so you know how to do that.
Okay.
Can you do you have a camera phone?
I do, but only the back-facing camera works, so if I take any pictures, they're going to be in reverse.
You said y equals sine of you said 0.5, and then you weren't sure, a bracket?
It's like exactly the same as a bracket, but it's not like, it's shift 9 and shift 0. I'm just drawing a blank.
Oh, that's parentheses. It's shift 9.
Okay,
What's the
all right.
rest of it?
For some reason, I'm
That's
sorry.
all right.
I'm sorry.
No problem.
X minus pi,
Okay.
then parentheses.
Okay. Cool. Yeah. So we're looking at a sinusoid function. Okay. The general equation of a sinusoid function is this. And I'm not sure how much of this you've had. You may have had everything but the C and the D. Have you had the whole thing?
I think everything but the C and the D.
So you've had the general form you've had is this. Now you must have had the C because we have a C here.
All right. Well, I don't know about the D.
Okay. The D is just a vertical shift. Okay. But the A is amplitude. And the B affects the period. Let's talk about what questions are they asking you about this?
Right now it's just asking me to graph each of them.
Okay, cool. Very first thing we need to know is how to graph this. And this is a graph you want to memorize. You want to memorize the sine and the cosine. Okay? And everything I draw on here you want to memorize. All the key points. Sine starts at 0 and is 0, at 0. It goes up to its highest point 1 at pi over 2. Comes back down through the x-axis at pi. Goes down to its lowest point, which is minus 1, at 3 pi over 2, and comes back to its starting point at 2 pi. So everything you see in front of you, you want to be able to recreate from memory.
All right.
Okay? Very important. As long as we're talking about these curves, let's look at the cosine curve. Notice the primary difference is the cosine curve. The cosine of 0 is 1. But the key similarity is you break it down into quarter points. Both have a natural period of 2 pi, and both, if you break it down into its quarter points, you will see that those are key points in both curves.
Okay.
In other words, with cosine, at 0, we start at 1, its highest value it can possibly be. It goes down to 0 at pi over 2, down to negative 1 at pi, up to 0 at 3 pi over 2, and finally back to its starting point at 2 pi. So everything you see on the page, you want to be able to recreate from memory. Colin, refresh me again. What year are you in high school?
I'm a junior.
Okay. So you're not done with trig. You're going to have it in some form next year. You're taking pre-calc trig this year?
No, I'm taking algebra 2 with trigonometry.
Ah, okay. What are you going to take next year? Do you know?
Yeah, I'm taking pre-calc.
Okay. You're still going to need a lot of trig. And these are the two most fundamental graphs there are for trig. So you want to be able to, you want to memorize everything you see on this page, pretty much. Let me erase this part here. Now you want to memorize everything you see. Okay? So now let's talk about how we can vary these curves. Well, if I say, if this is all you've learned, well then let's just talk about this. You must have learned the C, because the one you gave me has a x minus pi. There's actually a plus d also on the end of this. what are the consequences of A? Let's say I had y equal 2 sine of x. What would that do to my sine x curve?
I honestly don't know. I missed a lot of
Okay,
class
it's
because of.
pretty simple. It acts as a vertical stretch factor.
Okay.
So it would go up to 2 and down to negative
And
2.
okay.
In other words, it would be as if this was made of a string, you pulling up on that point and pulling down on that point. So it does change the shape of the curve. It's just like a leading coefficient is with polynomials. It acts as a vertical stretch factor. What is the consequence of B? It's a horizontal stretch factor.
Okay.
Okay? So if I said, well, what if I had the sine of 2x? Let's label all of these. Here, let me label this one. That is y equal 2 sine of x, because it's really worth analyzing these one at a time. Now, if I wanted y equals sine of 2x, then it's not a that's 2, it's b. And b has an effect of horizontally scrunching or stretching my curve. Well, there's a very important relationship you have to remember, which is that b equals 2 pi over the period of this function. Which means, if I algebraically manipulate that the period must be equal to 2 pi over b. So the problem, well, let's look at the one I've created here, sine of 2x. What's b?
2.
What would the period be?
2 pi over 2.
Which is just pi.
Yes.
Which means I have to draw this entire curve between 0 and pi. So
Okay.
I'm going to draw it in blue. It's still only going to go up to 1. But now it's going to come down through that quarter point. It's going to go all the way down to negative 1 and end right there. So you can see that this 2 has had the effect of pushing on the outsides, scrunching up horizontally that curve.
Yeah.
So whenever b is greater than 1, it has the effect of scrunching up our curve horizontally. When b is between 0 and 1, like the problem you gave me, it has the effect of stretching the curve. So the problem you gave me has a b of 1/2, 0.5. So let's, on a separate page, graph just that. I'm going to put 2 pi right there. And I'm going to put 4 pi right there. And I'm going to draw this graph in red. What is b?
0.5.
What is my period? Which, before I can draw the graph, I got to know my period.
I don't know what a period
The
is.
period, I'll show you in a moment. The period is 2 pi over b, so it's 2 pi over 1/2, which is 4 pi. That means I have to draw my curve between 0 and 4 pi. So it's still going to go up to 1, still going to go down to -1, but now it's going to hit this point, this point, this point, and this point. Whereas the sine of x went between 0 and 2 pi. It drew one complete period between 0 and 2 pi. This one, the period is stretched out to 4 pi. Okay? Now, let's talk about period. Let me draw a full sine curve. A full sine curve continues to oscillate forever and goes in both directions. This is actually the sine of x. Before I was only drawing one period of it. Now, one period can be measured peak to peak. That's a period. Valley to valley. That's a period. Similar starting point to the next same similar starting point. That's a period. They're all the same.
Oh, okay.
Okay? So when I ask what the period is, I mean how far on the x-axis is it from the starting point to where it would start again.
Okay.
Okay?
That makes more sense.
And in my case, the only information I have is that b is equal to 0.5. So you have to memorize this right there that I've circled. Your period is always equal to 2 pi over b for sine and cosine, which makes b equal to 2 pi over the period. Because sometimes they're going to show you a graph and ask you to write the equation of that graph. In other words, you have to go both ways. You have to be able to graph a sinusoid equation, and you have to be able to look at a graph and figure out what the sinusoid equation is. Those two things. Okay? So, we're still not really done with your problem because you have an extra thing. You have a b that's that, but you also have something inside the parentheses, which is a minus pi. So you have a c also. C, when it's in this format, is the phase shift, which is really nothing more than a horizontal shift. Okay?
Okay.
Take this curve that I've drawn. C is positive pi, because the standard format is x minus c. So in our case, c is a positive pi. A positive pi means shift it to the right. So instead of starting at 0, I'm going to go over pi units and start my curve right there. Okay. Now, I'm still going to have a period of 4 pi. So my curve for the function that you gave me the very first thing I'm going to do is a normal sine curve would start there, but I'm going to do a phase shift of pi. So instead, I'm going to start right there. My period is 4 pi, so I'm going to begin and end my function going from pi to 5 pi. So I'm going to end one period right there. There, a is 1, so I'm only going up to 1, I'm only going down to minus 1. The next step to graph this thing is to quarter this thing up. So what are my quarter points between my start and my finish? What is this one right here?
3 pi.
What's this one?
2 pi.
And what's this one?
4 pi.
Okay. So I know I have to start here. I go up to my maximum at my first quarter point. I come back down through the x-axis at my second quarter point. I go down to my minimum at my third quarter point, and I finish back where I started. Now connect the dots with a curved line. There's my graph. Now, is all I've graphed is one period of this thing. If I were to continue graphing it, it would look something like this. But usually you only have to graph one period of it. However, sometimes they're going to give you a graph and ask you to write the equation of that graph. And the graph they will give you will have multiple periods on it. In other words, they might give you this graph. Okay, so you would have to figure out what the period is. Well, I would look, well, that starting point starts at pi. This one ends at 5 pi. So I know the period must be 4 pi. So I would be able to say the period equals 4 pi. I also know the period, I'm trying to figure out what b is. B is equal to 2 pi over the period. So b is 1/2. So if you ask me to graph the function from this, if you ask me to write the equation from this graph, I would be able to see that the period was 4 pi, which means b is 1/2. So now I've got most of the function, as all I need is b. And there's a phase shift. I can tell it's pi, so there's my function. So I can either write the function from the graph, or I can graph the function from the sinusoid equation. Okay. And let's just talk about d, because the fact that you have a c here leads me to believe you may actually have d. All d does is vertically shifts it up or down. Does not change the shape. So if I wanted to graph sine of 1/2 x minus pi plus 2, I would move my line of symmetry, my horizontal line of symmetry, which is now on the x-axis, up 2 units to there, draw a dotted line across, and redraw this graph about that new line. In other words, I would still start there. I would go up to there. You see what I'm doing?
Yeah.
So the only difference by having a D is that there is a vertical shift. Same as with any polynomial. In other words, this is no different than if I said, how do you graph y equals x squared? Well, that's this parabola with its vertex at the origin. And now if I said, well, how do you graph y equals x squared minus 1? Well, that is a vertical shift. So I take my parabola, I move it down 1, and I redraw the same shape, only going through the y-axis there. In other words, whenever you take a function and you add or subtract a number to the end of it, it's strictly a vertical shift. Same.
Okay.
And in fact, everything about the sinusoid function applies to polynomials like this. If I want to vertically shift this, I add a number. If I want to vertically stretch it, I say y equal 2x squared. The 2 is in front of the function. That acts as a vertical stretch factor, just like it does with a sinusoid, the amplitude. If I want to horizontally scrunch it, then I would put the 2 inside the parentheses and square it. That has a similar effect, really vertically or horizontally scrunches it. And if I want to shift it, Laterally, horizontally, I'd say x minus 1 quantity squared, and that is a shift to the right of 1 unit. In other words, the vertex is now going to happen right here. So I would graph it like this. Same shape, is all I've done is shift it to the right by 1 unit. Okay? So all of the things you learned for polynomials still apply to the sinusoid function. I've always been amazed that they don't talk about it in the same way. You go to any trig class and they'll call this the amplitude. They'll call this relates to the period. They'll call this the phase shift. And they'll call this the vertical shift. But why they use different names, I don't know. Because that's just a vertical stretch factor, that is a horizontal stretch factor, that is a horizontal shift, that's a vertical shift.
All right.
Do you have another problem?
Yes.
We've only got 5 minutes, so you may want to do a trig or you may want to do a log problem.
Okay, here's a log one. Log base 3 in parentheses 2x minus 1 equals 2.
Okay. Put this in exponential format.
Okay, what's the equation again?
Okay, the important thing to remember is that logs are exponents. So there's my exponential equation. What's the logarithmic expression of this?
Log, and then
Base what?
b.
Base b. What?
And then, is it y?
Correct, because logs are exponents. So we have to have the exponent on the other side of the log. Okay, so if I gave you this, the exponential expression is the number on the far left raised to the power of the number on the far right equals the number in the argument. In other words, b to the x has to equal y. Well, apply that to the problem you gave me.
Okay, so it's going to be 2x minus 1 equals 2 to the...
Tell you what, use my memory technique here. If I want to convert this to an exponential expression, it's real simple. Take the number on the far left, raise it to the power of the number on the far right, and it's equal to what's inside the parentheses. So just do that.
Okay, so it's 2x minus 1
Well, let's start with the other. In other words, let's write it as you memorize it. 3 squared equals what?
Equals 2x minus 1.
Okay. It may seem like a trivial point, but in math, where there's tons of memory involved, anything you can use to help you, you want to use. Okay?
Okay.
Now solve this equation.
Okay, so it would be subtract or add 1 to the other
All
side.
square 3.
Yeah. So that's 9 equals 2x minus 1.
Okay.
Now you add 1 to the other side.
Okay. 10 equals 2x.
Then you divide by 2.
X equals 5. That's the solution to that logarithmic equation. Okay? And the key lies in being able to take this log equation and turn it into an exponential equation. So do you have another one real quick? Another log question? Let's reinforce that point.
Yeah, so 5 to the log, or to the power of log base 5 and then in parentheses x equals 3.
Okay. Whenever you have b to the log base b of x, that's always equal to x, whatever is in the parentheses. Because this raised to that cancels it out. So I can say this whole thing is x. That's the solution. And it would be the same if I said 6 to the log base 6 of x minus 1. That whole expression is equal to x minus 1. That expression right there. In other words, whenever you have b raised to the log base b of some argument, it's always equal to the argument.
Okay.
It's kind of like another thing is log base b of b is always 1. So if they said, what is log base 3 of 3, it's always 1. Why? Because 3 raised to the 1 power is equal to 3. Doesn't matter what this base is. If it was 7 and that was 7, it would still be 7 to the 1 power equals 7. So the net result is the log of any base, that's always 1.
Okay.
All right. Colin, you have any last questions?
Not really.
Can I ask what website you used to schedule your session? Was it Digital Math Tutor or Algebra to Calculus? Do you remember?
I'm pretty sure it was, wait, I'll just look real quick. I have my email up. I used ginbook.com.
Ah, okay. That's the scheduler I use on my website, but I use it on both, so I can't tell which one you used. The only reason I'm writing this is because if your parents are going to pay for this with PayPal, it's easier to use that site. If they're going to send me a check, it doesn't matter which one you used. I actually do have 2 websites. The other one, which is just not quite as easy to pay with, is Algebra to Calculus Tutor.com. So it's real close, but it's not quite as smooth. This one here is a one-step payment process. If you click on the Buy Now, you just need to fill in $18 or $36. And in your case, it would be $18 because it's just a half-hour session. Okay? So if your folks have a PayPal account and they want to use it to pay this, I would suggest going to Digital Math Tutor, have them find the Buy Now button, and it'll be real simple. If they want to send me a check, they need my address. You want me to write that down here?
Yeah, that'd be awesome.
And have them make it out to me, not my company. There's where they can send it. 7320 Quarry Mountain.
All right.
Okay. And let's see. I have your email. So this thing will be, and you know where to get the recording of this, correct?
I don't think so.
I'll send you a link in the morning when it's ready. It won't be ready till tomorrow morning. It takes 3 or 4 hours for my computer to process it. but I'll resend you that link as to how to see that session. It can be pretty valuable to be able to go back and review. It's like, say you forgot what the relationship between logs and the exponential equation is, you could go back and look at it
Okay.
on the recording. All right, Colin, I will let you go, and I will talk to you next time.
All right. Yeah. Thank you so
You're
much.
welcome. Bye-bye.